So we will start our today's session with hierarchical clustering. So hierarchical clustering is a way of grouping objects or variables according to their similarity, according to their similarity. And then we will represent those joinings in a tree like this one. Okay, so at the beginning, this is an agglomerative approach in which at the beginning all the objects or all the variables are independent from each other, and then they are grouped according to their distance. So let's say that in this example, x1 and x2, that are two variables, let's say, they are closer to each other, so they are joined into a single group, 1, and then x4 and x5 are grouped into 2, and then x3 is joined with the group 1 to make the group 3, and then group 3 and group 2 are joined into group 4, and then the group 4 is joined with x6. And now at this point all the input variables have been merged into a single group so that we cannot further proceed. So we have finished the algorithm. So here we have an example. So let's say that we have 5 variables. We can see here that x1 and x3, they are very much correlated, and the same for x2, x5. So the dissimilarity is 1 minus the correlation coefficient. So the higher the correlation, the smaller this dissimilarity measure will be. So we look for all possible pairs, which are the two that are closer to each other. And in this case it is x1, x3 that are very much correlated, so the dissimilarity is small. So we merge them, and we will see at which height we merge them. But we merge them soon, and then the same happens with x2, x5. So they merge later because they are more dissimilar from each other. And then these two groups are merged together at a level of 0.7, around 0.7, and then x4 is merged at the end. So x4 is the most dissimilar of all of them, and then it comes much later. And the number of groups have to be manually selected. There are some techniques like the cophonetic index that helps you to choose the number of clusters, but otherwise you can in many classifications you can choose manually the number of clusters. And the way to do that is to select a threshold. So for instance, let's say that we choose a threshold of 1, and then below a threshold of 1 we have all the variables, and then let's say that we take 0.75 like in this one, and then we are crossing 2 points, and these 2 points make the clusters to be x4 independently, and then x1, x3, x5 and x2 all together into the same cluster. But then if instead of 0.75 we take 0.65, that is this other line, then we have 3 clusters because we are crossing the tree at 3 points. So we have x1 and x3, x2 and x5, and x4. The same happens with 0.3. We have 3 clusters. So that there is a long range of thresholds for which we have 3 clusters. So probably 3 is the best choice in this example. And then if we go further down, we go to 4 clusters. That would be x1 and x3 all together, and then x5, x2 and x4 independently. And if we go further down at the end, we would have 5 clusters that are the 5 input variables. So we defined in the previous session what was the distance or dissimilarity between 2 objects or 2 variables, but now we will have to define the distance between two groups. The reason is that at some point we are joining groups. For instance, here we are joining group 3 with group 2, and we have to make pairwise comparisons between groups or groups and variables. A variable can be considered a group of size 1. So at some point we are measuring the distance between groups, and we have to extend the concept of the distance of two objects to the distance of a group. So when we have two groups like this one, we have to decide what is the distance, not between two particular objects, but between two particular groups. And this is called the linkage. And the linkage, there are three ways, that is complete, average, and single. So complete is the distance between two groups is defined as the distance, as the maximum distance between two objects in each one of the groups. So for instance, between these two groups, the most distant objects are this one, and this would be the distance between the two groups. The single is just the opposite. So two groups are the distance between two groups is defined as the minimum distance between points of these two groups. So for this example, we would have here probably the most the closest objects. So this would be the single or the distance defined by the single linkage. This would be the distance defined by the complete linkage. And then we can also compute the average. So we can take all possible pairs between points of this group and points in this group, compute the distance between those pairs, and then compute the average. And this is called the average linkage. And complete groups, complete linkage tends to make groups that are globular. Single linkage tends to make groups that are very well connected, and the average is some kind of compromise between the two. And here you have a textual description of what I have just said. Okay, so here we have some examples. So choosing the linkage makes a difference at the level of what is the final clustering. So we see that the trees are different for this for this input data set. So it makes really a difference, and you have to choose the several linkages and then choose the one that better fits your need. So let's see how the distance is calculated. Okay, so let's say, just to put a simple example, that we have three variables with 5 observations. This is the scatter plot between all possible pairs. This is the correlation matrix, and then we compute the 1 minus correlation matrix, that is the dissimilarity between elements. Then we have to choose which is the pair that is closer to each other. So x1, x3 has a dissimilarity of 0.73, and the rest of the similarities are higher. So x1, x2 or x2, x3, they're higher. And so x1 and x3 become together at a height of 0.73. Now we have a group, and we compute the average. So let's say that we are using average linkage. So now we compute the distance between x2 and the other two variables and the other group, because now we have a single group. But to do that, we compute the distance between x2 and x1 and x2 and x3, and then we compute the average. So the distance between x2 and the other two variables, x1 and x3, are these two numbers in blue, and then we compute the mean. The mean is 1.00, and then x2 comes together with x1 and x3, with the group x1 and x3 at 1.005. So the point is that we merge the groups in this axis, at the height given by the distance between the different groups. Then we can also use hierarchical clustering to cluster observations. Now the distance would be the distance between objects, and then for instance here we have different Euclidean distances in this case, and the point at which they merge. So we see that we have clearly three clusters. So we have one cluster there, one cluster there, one cluster there. And if we map these labels onto the input data, we see how these three clusters are mapped into three distinct regions. And as I said before, the complete linkage, that was the linkage that we have chosen in this case, tends to make globular groups. So this is kind of circle, another circle, another circle. So let's see more examples now, classifying or clustering variables. So let's say that we have 5 independent variables. So we have here the 5 variables. There is no correlation between the 5. We have 100 observations. This is the correlation matrix. And then when we do the hierarchical clustering, we see that all the variables come together at a very high distance. So that means that the variables are not similar to each other at all. Now let's say that we have very highly correlated variables, and in this case they come together at very low distances, meaning that they are very much similar to each other, all the 5 of them. Then we can have another example in which you may remind in this example in which we had several signs. So this is the scatter plot between the different variables. Some of them are more similar to each other. So for instance, we see x1, x2, and x3. They're relatively similar. So here we have 1, 2, 3 that come together relatively soon. And 4 and 5, we can see also here that they are more similar to each other. And then if we go, let's say that we make a cut at 3 at a level in which we have 3 independent groups. So this was the data underneath, on top of which we had noise. So these are noisy versions of these ones. So we see that cluster 1, that are the most similar to each other, they are the signals 4 and 5, that they are really close to each other. And then the cluster 2 is made of variables 1 and 2 that are not so similar as x4 and x5, but they are closer. And then x3 comes a little bit in between. So here this is what is represented here. So x4 and x5 go together, then x1 and x2, and then x3 comes later. And here is another example, and in this example, let's say that you have a circuit or a plant or whatever, and then you measure many tensions or intensities or any other variable along the circuit, and then some of the variables will be more related to the rest. So this is what is represented here. We have all the variables and then the different distances, and this is hierarchical clustering between all those variables. So this is all for hierarchical clustering, and next session will be about k-means.